So what if you could take regular 2D videos, like off these Meta Ray-Ban glasses, iPhones, GoPros, and fuse them all together to create a 4D reconstruction that you can replay from any angle? Classify every hit or miss, the exact target that you hit, and even see the targets through walls. And the best part is, I had my agents doing the heavy lifting while I slept overnight. It honestly feels like a janky prototype of the brain dances from Cyberpunk 2077 if it had a baby with a defense tech product. Let me show you how I built this and how you can too. Let's get into it. So this is what it looks like. Basically, every single hit or miss, all the targets are tracked, and as you can see, you can even see them through the walls. And as every hit or miss happens, the shots are classified and show up in the shot counter over here. And since my buddy's wearing a pair of Meta Ray-Bans too, I'm able to fuse these clips together to create this 4D reconstruction that you see over here. That's my stick figure taking the shots, that's my point of view, that's the observer chasing behind. As you can see, all the shots are perfectly tracked. And as the hits and misses happen, again, it gets classified over here. And let me tell you, you could get fancy with it. This is my buddy doing a really good run over here. You could see just the scale and scope of what actually works and how accurate the tracking actually is. I've got this timeline down here that shows you visually every single hit or miss as well. You can check out just how complicated this one is in particular. Easy. Full body pose estimation, target tracking, all the good stuff. So this all actually started as an experiment in the middle of last year. This was like, June of 2025. And the idea I had was to use Google's multimodal AI models, Gemini, that can reason about audio and video. And I wanted to use that ability to create this sort of a shot counter. And back then, it was really, really janky. It didn't have a good idea of like what targets were being hit. And I would have it create this like After Effects script that I would then go and run to create this nice overlay. So when I got done with this experiment, I obviously had this like desire to take this further and a pretty ambitious roadmap. I wanted to do 3D reconstruction so you could get like a top-down view or whatever view you like. I wanted to have proper camera tracking, support for multiple cameras getting synchronized together. Now I had filed this under someday, I'll get to it at some point, and then Fable 5 dropped and I was like, okay, let me put this to the test. And I literally blitzed through most of my roadmap in just a couple days. So this is the web UI that I built. Basically, you can see all the tracked workflows then get overlaid on top of my browser and I can scrub through it in real time. That's the cool part about this. I can jump around very easily, spot check to see if the model is actually doing the right thing that I wanted. And so if I come to the God's Eye tab over here, I can see the 4D replay. So I can take control of the camera at any time, move it around easily, follow my friends. And I made a bunch of presets where the camera can like literally follow the person like a drone. It could frame all the shots that you're hitting. You could just do a clean little orbit. And of course, you can even keyframe stuff yourself. So here's more multi-camera footage. You can easily take the shots. You can see them. Real-time compositing in the browser. Works really well.
Yes! Let me just...
And of course, I had to miss that shot.
It's okay, the video cuts off right there.
That's right, you just cut off the video right before you embarrass yourself. And here's the exact reconstruction now from a God's Eye view perspective. And similar to before, as I said, I can take control of the camera and look at it from any angle. Now you may be wondering, how the hell does this work? Let me show you. All right, so here's the full picture in one slide. My requirement was pixels only. I don't want to deal with LiDAR, depth data, IMU, all that. Certainly it could help, but most people don't have that. And when you're out on the range, you want to be focused on shooting, not carrying around a bunch of heavy equipment. So just pixels in, no other fancy sensors. With that, what I do is an audio synchronization. And if you're familiar with video editing, you know this is pretty easy. Shots obviously show up in the waveform beautifully. So here you can see in green and yellow the two different clips, very easy to synchronize them, and they pretty much line up. Then I want to do a joint solve. Basically, I want all of these videos to be in the same three-dimensional space anchored over time. Now for this solving, I wanted to try a bunch of different approaches, and this is where it's honestly a joy to work with the latest LLMs like Fable 5 and Codex 5.6. Basically what I would do is queue up a bunch of experiments, all the directions that I would have tried, let's say over the course of many days, and ask the AI to crank on it as a goal overnight. So what I had the model do was create these like top-down trajectory maps. So basically, if I take a reconstruction like this and grab it from the top, you get a view kind of like this, and I can see the path that the person's taking, especially any deviations that happen when it loses tracking and so forth. So that's what it's doing over here, is you can see very clear trajectory, and then Lingbot map, even though it's real time, oh gosh, it's just like all over the place. And this thing was smart enough to be like, all right, well, I'm basically seeing COLMAP and Pi 3 are nearly the same curve. Let's go with those two approaches, one as the primary and then the other as the fallback. And this part is so magical, right? Like these are things that I would have to do, prompt it heavily to do it. Now I can give it this like 20-minute voice note of like all the experiments that are in my head. It'll go and create this board of them and literally come back to me with results to review in the morning. I mean, this is obviously the problem with this is like, I need to queue experiments up overnight so I can get up in the morning and see what it came up with. Now you may be wondering, how does this help me see where the targets are and track them over time? Let me show you the before and after reconstruction. So on the right here, you see the real frame of footage. And then as I swipe over, you're seeing the 3D reconstruction perfectly aligned to that frame. And as you can see right over here, those targets stand out beautifully. And there they all are. So when an AI model figures out what was hit in 2D space, it can project it into 3D, which is exactly what makes persistent very easy. This is a particularly cool example because notice over here, you've got targets here in the back and over here too, through the wire mesh, that any regular 2D model would not be able to tell that that's a target. But if I swipe over and I show you, we can literally see through the walls and see those targets perfectly. This way, an AI that's trying to classify a hit or miss has a much deeper understanding of what's going on in any single image. And that's actually how shot classification works too. So with all the hits and misses, what I have it do is like take those feature points, zoom in on the image, and send a couple of frames before and after the shot and have a video language model like Gemini reason about if that was a hit or miss. Mostly it gets it right. And if it doesn't, it just tosses it to me in the morning for human review, which is also pretty cool, right? So for this kind of human review, I had my clanker build me an annotation tool. So basically I can go into any clip over here. I can see all the hits and misses. I can hit the arrow keys basically to jump to the next shot very easily. So anything that it got wrong, I can go in here, basically go draw a bounding box around the actual thing that was hit. So it's very easy to correct as well. And the beauty of it is all this data is then used by the AI to refine its own classification. So it keeps getting better. So that's the workflow in a nutshell. You find the when, right, with the metronome of the shot. You judge the hits or misses, right? The AI looks at the crop of the 3D feature points in the 2D image, grabs those, looks at that clip and says, yes, that's a hit or miss. I spot check it and fix whatever's wrong. And then basically, since all the cameras are synchronized, you get the second camera for free. And just with a little bit of labeling, I went from 87.5% accuracy to 97.9%. Shout out Richard Ryan for sending me these clips. In this case, it is a GoPro that's looking at Richard over here, and this is the first-person perspective. Works just as well. I mean, I'm honestly kind of amazed how easy this was to put together compared to just what it would have been even a few months ago. And here's the God's Eye View replay of the same run that Teddy just did with a rifle. You can see him popping over here. Cardboard nicely reconstructed. Jumps over here, tracking loss, recovers beautifully. And on it goes. I mean, this is just so much fun. Like, it was so cool to take like my mapping knowledge and my augmented reality work previously and kind of like fuse it together in this amazing prototype. So if we replay from that first person perspective, you can say we take that God's Eye View 3D view and sort of project it into 2D space. So thus you can see all the targets through the walls perfectly. All the hits being made.
Safety first, kids.
Safety first, indeed. Since it's first-person view, the best part of this clip.
You want to attempt?
He was teaching me how to do this trick. Check this out.
That was fun.
Too much fun. So with that level of curation and control, I mean, you could imagine use this for like target shooting, all sorts of practice drills, but also just generally 4D reconstruction. Think about how many things happen in the real world where there are multiple people with phones that are recording an event that's going down. You could use a technique like this to create a full-blown reproduction using crowdsourced footage. And in fact, I've talked about the static version of this in this previous video over here, how you could take everyone's vacation photos and turn it into a 3D reconstruction of all the stuff that doesn't change. But if you have multiple clips that are recorded at the same time, you can create a 4D reconstruction of what actually happened. Now, since I mentioned static 3D, there are some limitations here. So if I take a sequence like this, where I'm hitting static targets, that's fine. But the moment you're hitting something like this that has like a spinning star and the geometry itself is moving, you're not going to be able to reconstruct that well at all. And so as a consequence, you can see the AI thinks that I'm hitting the spinning star right there in the middle. Now look, as these models keep getting better and faster and able to run on the edge, I think this type of hit or miss detection and shot classification you'll be able to do in real time. Like that's basically what the Anduril headset is trying to do, right? Eagle eye. But if you take a look at where these feed-forward approaches are going to do like real-time reconstruction, gosh, I think we are not that far from that either. Now, there's a bunch of other features I want to build, like basically get a Spotify rap style card of like, here's how your session went. Maybe even get some like coaching from the AI model. But the big idea being, take any regular old 2D videos of the same thing happening, have it automatically synchronized, 3D tracked, reconstructed, classified, ready to produce immaculate output. Videos that you can share online, and of course, a live browser where you can explore the scene from any angle. What a time to be alive. It's funny, a buddy at Google Research actually saw my reconstruction, was joking, he's like, this would have been a SIGGRAPH research paper just a few years ago. And now it's honestly like a weekend project. Now, if you just take this video that we just watched, throw it into Gemini, or just grab the transcript and give it to your AI, it'll help you reproduce the same thing. And you can learn from all the lessons and mistakes that I made. Anyway, stay tuned for more mad science experiments. If you've been waiting on the God's Eye View open source release, well, I got some good news for you. It is dropping in July. The GitHub repo as a placeholder is already up, so go ahead and start it, watch it to get notified when it drops later this month. And thank you so much for voting. As we decided, V1 is going to be open source and free. V2 is going to be the paid product. For V1, it's going to be God's Eye View Live Edition. Now, if you're curious about what you could do with military-grade technology to take these kind of camera systems and create a 4D reconstruction of an entire city, you're going to want to check out this video over here on Whammy. Bilal signing off, and I'll see y'all in the next one. Cheers.